This video is for anyone looking for a way to avoid the void using cored wire, including causes of voiding and the properties of Indium Corporation's wire that minimize this challenge. Eric, is using the correct wire cored solder important to avoiding solder joint voids in robotic soldering?
It is, very much so, and it's a good topic to discuss because we definitely see a proliferation of robotic soldering to replace pin and paste processes as well as traditional manual hand soldering type processes. And the selection of the wire, the cored wire, is very critical. Obviously, you have to have the right alloy, hopefully that goes without saying, and also the flux is extremely critical. The type of flux, which is often tied to the activity of the flux, is critical, as well as the percentage of flux or the amount of flux that's actually in the wire itself. And of course, the fact of having no voids in the core of the wire itself, continuous flux throughout the length of the wire. And a process that uses wire as opposed to using solder paste will actually give you less voiding and better hole fill. And there's two basic reasons for that. One is that there is simply less flux in cored wire as opposed to solder paste. So there's less flux that the solder has to displace or move out of the way when using a flux-cored wire. Right. So less voiding as a result of that. Also, because of the way fluxes in cored wire are formulated, they have less volatile components right from the chemistry point of view as opposed to a solder paste flux. So they just simply outgas less. And of course that reduces the amount of voiding as well.
Well, in addition to optimizing the core wire itself, what kind of process optimization is needed to create void-free robotically soldered connections?
A lot of the same logic and precepts that apply to paste reflow soldering and wave soldering also apply to soldering with a flux-cored wire. And the big one is heat, because you're relying on just a little point connection, if you will, or point contact to transfer that heat into what you're trying to do. So that sufficient heat is important because you want to sufficiently activate the flux. You want to sufficiently heat the surfaces that you're soldering to so that you get good flow and a metallurgical bond. And what's also critical is, avoiding some of the sophomore mistakes that we've probably both encountered on the factory floor, where somebody's actually taking the iron and basically wetting the solder to the iron and hoping that it drops down and on whatever they're working and makes a solder joint that way. There's some inherent problems with that. One is that you can prematurely exhaust the flux because you're not, and the second thing is because you're not transferring the heat directly to what you're working on, the solder won't wet to that surface and ultimately result in either a poor or no metallurgical bond. And also from a cosmetic point of view, you can get what is known as a cold solder joint.
Very good. Where can we go for more information, Eric?
People can go to our website, indium.com, or they can send us an email at askus@indium.com.
Very informative. Thank you, Eric.
You're very welcome, Phil,
Appreciate it.
anytime.